January 3rd, 2019, the far side of the Moon. A small lander sits motionless in the perpetual silence of Von Karman crater. No human has ever stood here. No spacecraft had touched this ground until 8 hours ago. Inside a sealed aluminum container the size of a coffee can, something remarkable is happening. Cotton seeds are sprouting. For the first time in 4.5 billion years, green leaves are growing on the lunar surface. The Chang'e 4 lander carried this miniature biosphere: cotton and potato seeds, fruit fly eggs, yeast, all packed with water, nutrients, and a controlled atmosphere. Chinese scientists watch telemetry data from 384,400 kilometers away as the cotton seedlings unfurl in 1/6 Earth's gravity. Temperature inside the container, a stable 24 degrees Celsius. Outside, the surface swings between 127 degrees in sunlight and negative 173 in shadow. The plants survive 9 days. Then lunar night begins. The heating system, designed only for daytime operation, shuts down. Interior temperature plummets to negative 52 degrees Celsius. Within hours, everything inside freezes solid and dies. This single experiment, this brief flash of life in the most hostile environment humans have ever reached, reveals both the audacity and the challenge of what China is attempting. They're not planning a brief visit to the moon. They're not aiming for symbolic footprints and flags. By 2035, China intends to construct a permanent base at the lunar South Pole, built almost entirely by autonomous robots using materials mined from the moon itself. The cotton plants that died in Von Karman crater weren't a failure. They were reconnaissance, a test of what it takes to keep anything alive in an environment that kills everything. And they were the first step in a 3-phase plan that will culminate in Chinese astronauts living in underground lava tubes beneath the lunar surface, protected by walls made of moon dust baked into bricks. To understand why China is building on the moon, you need to understand what makes the moon so brutally inhospitable. The moon has no atmosphere. That single fact creates a cascade of problems that don't exist on Earth. Without air, there's no protection from cosmic radiation, high-energy particles from the sun, and deep space that would damage human cells over time. Without air, there's no friction to burn up incoming meteorites. The craters covering the lunar surface aren't ancient history. They're an ongoing bombardment that continues every day. Without atmosphere, there's also no insulation. When the sun rises over a lunar crater, the temperature climbs to 127 degrees Celsius. When it sets, the ground plummets to negative 173 degrees. And because the moon rotates 29 times slower than Earth, each day lasts 14 Earth days, followed by 14 days of darkness. The Apollo missions proved humans could survive this environment, but only for 75 hours at a time. Neil Armstrong and Buzz Aldrin spent 21 hours on the surface before returning to orbit. The longest Apollo mission, Apollo 17 in December 1972, kept astronauts outside for 75 hours total. Then they left and never came back. For 52 years, no human has walked on the moon. But that's about to change. China's lunar program began in earnest in 2007 with Chang'e 1, an orbital mission that mapped the surface. Chang'e 2 followed in 2010 with higher resolution cameras. Then came the landers. Chang'e 3 touched down in Mare Imbrium in December 2013, deploying a rover that operated for 31 months. Chang'e 4 made history in January 2019 by landing on the far side, the first spacecraft ever to do so. Each mission built toward the same goal: gathering data needed to construct a permanent base. The orbiters mapped potential landing sites. The landers tested autonomous navigation and dust mitigation. The rovers analyzed soil composition. And that biosphere experiment in 2019, despite its short life, proved that maintaining Earth-like conditions in a lunar environment was theoretically possible. In 2020, China returned lunar samples to Earth for the first time since 1976. Chang'e 5 collected 1,731 grams of regolith from Mons Rumke and flew it back to Chinese laboratories. Scientists studied the material's properties, its density, composition, melting point, structural strength. They weren't just doing geology, they were studying construction materials, because China had already decided they wouldn't ship building supplies from Earth. The cost would be astronomical, roughly $1.2 million per kilogram, just to deliver materials to lunar orbit. Instead, they would use what was already there. The technical term is in situ resource utilization. The practical term is building with moon dirt. That's phase 1. Reconnaissance. Understanding the environment and mapping the resources. China is approximately halfway through this phase now, with additional robotic missions planned through 2028. The breakthrough came in 2024 when Chinese materials scientists successfully baked lunar regolith simulant into load-bearing bricks. The experiments happened in laboratories in Harbin and Beijing, using synthetic material that matched the chemical composition of samples returned by Chang'e 5. Researchers packed the simulated regolith into molds, then heated it to 1200 degrees Celsius. What emerged were dense, dark grey blocks with compressive strength exceeding conventional concrete. The bricks could withstand impacts. They insulated against temperature extremes. Most importantly, they could be manufactured using nothing but lunar soil and solar-powered ovens. No cement needed, no water, no binding agents shipped from Earth. This solved the fundamental problem of lunar construction. How do you build anything when transporting materials costs more than the structure itself? The answer was simple. Don't transport materials. Make them there. In 2024, China and Russia announced a partnership to develop nuclear power plants for the lunar surface. Russia's state-owned Rosatom, the world's largest manufacturer of nuclear reactors, would provide the expertise. China would provide the integration with their lunar infrastructure plans. The logic made perfect sense. Solar panels work fine during the 14-day lunar day, but they're useless during the 14-day night. Batteries capable of storing 2 weeks of power would be prohibitively heavy. Nuclear reactors, however, generate continuous power regardless of sunlight. And on the Moon, cooling them is simple. Just keep them in permanent shadow. No risk of meltdown when ambient temperature sits at negative 173 degrees. Russia had already built a floating nuclear plant in the Arctic Ocean. A lunar reactor wasn't significantly more challenging, just different. And Russia needed a meaningful role in the Chinese moon program after their Lunar 25 probe crashed in August 2023, ending any hope of contributing through their own missions. By 2024, the pieces were falling into place. China had proven they could land spacecraft reliably on the Moon. They had returned samples and analyzed construction materials. They had designed concepts for autonomous robots capable of manufacturing bricks from regolith. They had secured a partner for nuclear power generation, and they had identified the perfect construction site. The lunar South Pole contains the highest concentration of water ice in permanently shadowed craters. Water means drinking supply, breathable oxygen when split through electrolysis, and hydrogen for rocket fuel. The South Pole also has peaks of eternal light, ridges where the sun never fully sets, perfect for solar panel farms. And preliminary ground-penetrating radar suggested the presence of massive underground lava tubes, natural tunnels carved by ancient volcanic activity. These tubes could be hundreds of meters wide, completely shielded from radiation and meteorites, naturally insulated from temperature swings. They were, essentially, pre-built habitats. All China needed to do was get inside them. Chang'e 6, 7 and 8 would complete reconnaissance between 2024 and 2028. Then construction would begin. Permanent habitation targeted for 2035. In 2028, Chang'e 8 will carry an experiment that represents the true beginning of lunar construction. The mission will land near Shackleton Crater at the South Pole, carrying a compact 3D printing system and a miniature brick kiln. For the first time, the goal won't be to gather data and return home. The goal will be to build something permanent. Autonomous robots will collect regolith and pack it into the kiln. Heating elements powered by solar panels will raise the temperature to 1200 degrees Celsius. Molten soil will be poured into molds or fed into the 3D printer. And slowly, over days or weeks, structures will emerge from the lunar surface. Not habitats yet. The first constructions will be simple. A landing pad made of fused regolith, capable of withstanding rocket exhaust without kicking up vision-obscuring dust. Then perhaps a small protective wall or radiation shield. Basic infrastructure proving the concept works. But if it succeeds, if Chinese engineers can demonstrate reliable remote manufacturing using only lunar materials, then everything changes. The limiting factor disappears. Construction no longer depends on Earth-based supply chains with million-dollar price tags per kilogram. It depends only on energy and time, both of which are abundant on the Moon. This is the fulcrum. This is the moment when lunar bases transition from theoretical proposals to engineering projects. And China plans to follow this with full-scale construction, beginning in the early 2030s. China's moon base construction plan focuses on robotic assembly before humans arrive. No grand visions of gleaming domes, no romantic architecture, just robots, bricks, and methodical construction. The International Lunar Research Station plan, jointly announced with Russia, envisions a robotic base operational by 2035. Construction involves multiple super heavy lift rocket launchers carrying modular components, power systems, telecommunications, research facilities, and resource extraction equipment. The habitat modules themselves use a design called the Moon Pot, a 3D printed dome made from 3 layers of fused regolith. The outer shell bears structural loads. The inner shell holds atmospheric pressure. Between them, a lattice of triangular ribs provides strength, like the internal structure of an eggshell. Total wall thickness, approximately 40 centimeters, enough to block the majority of cosmic radiation. The shape matters. Rectangular structures with corners are weak points for pressurization. Stress concentrates at edges, creating failure risks. Spherical and dome shapes distribute pressure evenly, like propane tanks and water towers. The Moon Pot incorporates this principle while remaining printable by a robotic arm, moving in horizontal circles, laying down molten regolith in successive rings that spiral upward. The brick-making process is straightforward but labor-intensive for robots. An autonomous excavator collects regolith and dumps it into a hopper. Pneumatic pistons compress the material into rectangular molds. The molds slide into a solar-powered oven where heating coils raise temperature to 1200 degrees Celsius for 90 minutes. Finished bricks cool for 30 minutes, then a second robot arm removes them and stacks them. A separate construction robot retrieves bricks and applies mortar, a paste made from regolith mixed with a polymer binding agent shipped from Earth. The mortar accounts for less than 2% of total mass, but it's essential for structural integrity. The robot lays bricks in traditional patterns, building walls, protective barriers, and eventually enclosed structures. For power, the nuclear reactor sits in a permanently shadowed crater, generating continuous electricity. Cables run to the habitats, research facilities, and manufacturing equipment. Solar panels on peaks of eternal light supplement power during lunar day. Water extraction systems drill into permanently shadowed craters, heating the soil to release frozen water vapor. The vapor is collected, purified, and stored. Some becomes drinking water. Some is split into hydrogen and oxygen, breathable air, and rocket propellant. The base expands gradually. First, the essential infrastructure: power, water, basic shelter, then research facilities, then resource extraction at larger scale. Each component tested remotely before humans arrive. As of January 2026, China is executing the reconnaissance phase ahead of schedule. Chang'e 6 successfully returned samples from the far side in June 2024, the first mission ever to do so. The samples contained regolith from the South Pole Aitken Basin, revealing minerals and rock formations from billions of years ago. Chang'e 7, scheduled for launch in 2026, will carry ground-penetrating radar specifically designed to map underground structures. The mission targets the South Pole, where data suggests the presence of lava tubes extending kilometres beneath the surface. If confirmed, these tubes become the obvious location for permanent habitation. Living underground solves nearly every environmental challenge. Meters of rock provide perfect radiation shielding. Temperature remains constant regardless of surface conditions. Meteorite impacts are irrelevant, and the tubes appear enormous. Some may be 300 meters wide, large enough to contain entire city blocks. China isn't sharing detailed plans for underground colonization, but the implications are clear. Surface facilities serve as entry points and industrial zones. Real living happens below, in thermally stable caves where pressurized habitats don't need heavy regolith shielding because the rock does it naturally. The timeline puts Chinese astronauts on the moon before 2030 in a short-duration demonstration mission. Then robotic construction throughout the early 2030s. Permanent habitation capability by 2035. This creates obvious geopolitical implications. The United States has its own moon plans through NASA's Artemis program, also targeting a lunar base at the South Pole. The timelines overlap, which means both nations will be competing for the same real estate, the limited areas where water ice and eternal sunlight coincide. The Outer Space Treaty of 1967 prohibits nations from claiming sovereignty over celestial bodies, but it doesn't prevent resource extraction or base construction. There's no legal framework for resolving disputes about who gets to build where. And the Moon's South Pole has a finite number of optimal sites. Russia's Lunar 25 crash in 2023 demonstrated that moon landings remain difficult even with modern technology. The probe lost control during orbital maneuvers and impacted the surface at high speed. Russia hasn't attempted another mission since. Their partnership with China on nuclear reactors represents their primary contribution to lunar exploration. Europe, Japan, and India all have lunar ambitions, but they're focused on individual missions rather than permanent bases. China stands relatively alone in committing to continuous robotic construction through the 2030s, with the explicit goal of permanent human presence by 2035. The question isn't whether China will build a moon base. The question is whether anyone else will build one fast enough to establish presence alongside them. Return to that aluminum container sitting in Von Karman crater, the one that held cotton plants for 9 days before everything froze. Chang'e 4 is still there, silent and inactive, solar panels covered in lunar dust. The biosphere chamber sits frozen, its contents preserved in perfect vacuum. Those cotton plants, the first green leaves ever grown beyond Earth, remain where they died, entombed in their little metal can. The experiment was designed to last 100 days. It lasted 9. Chinese scientists considered it a qualified success because the seeds sprouted at all, because they proved photosynthesis could occur in lunar gravity, because the data collected in those 9 days provided critical information about thermal management in sealed systems. But there's something poignant about those frozen plants. They represent both the ambition and the fragility of what China is attempting. Life doesn't belong on the moon. The moon is a dead rock that kills everything. Maintaining human presence there requires fighting every aspect of the environment continuously. One heating failure, one pressure seal breach, one critical component malfunction, and people die. Yet China is betting they can engineer solutions to all of it. Robots that build with moon dirt. Nuclear reactors that run for decades. Underground habitats where humans can live indefinitely. They're not planning an expedition. They're planning colonization. By 2035, if everything goes according to plan, a robotic base will be operational at the lunar South Pole. Shortly after, Chinese astronauts will arrive for extended stays. They'll be conducting research, extracting resources, expanding infrastructure. They'll be looking up at Earth, a blue and white marble rising over the grey horizon, thinking of it as home, but no longer as the only place humans can exist. And those cotton plants in Von Karman crater, frozen and dead but never decayed, will still be sitting there in the dark. The first attempt, the one that failed but proved it was possible, the first life the moon ever knew.